Now the next binary diagram is eutectoid diagram. Now in this diagram, eutectoid reaction takes place. According to that reaction, one solid phase on cooling changes into two another solid phases, alpha plus beta. Now this reaction takes place at constant temperature that we call as eutectoid temperature. Okay, that is the isotherm temperature that is called as eutectoid temperature. Now this diagram is something like this. Here I have one pure solid A, another pure solid B. Along this side I have temperature. Okay, so here I have weight percentage of B. Okay, this is isotherm, constant temperature line. So something like this. I have eutectoid diagram. So here I have one solid phase. This is one solid phase gamma, another solid phase alpha, third solid phase beta is over here. Here I have alpha plus gamma. Here I have gamma plus beta. Okay, and here I have alpha plus beta. Okay, so for this composition of A and B, eutectoid reaction takes place. You can see here on cooling, gamma changes to alpha plus beta. Okay, so this composition of A and B is called eutectoid composition, or you can say this is eutectoid alloy. Okay, so here along this region I have hypoeutectoid alloys, and along this region I have hypereutectoid alloys. Okay, so this is eutectoid diagram. The next diagram is peritectic diagram. Peritectic diagram. Now the example is AG and PT. So this diagram is like this. So here I have AG Here I have PT. This is the weight percentage of PT along this side. Along this side, I have temperature. Okay. So this is my isotherm line over here. Okay. This is peritectic diagram. So here I have the liquid phase. Okay. This is the alpha phase. This is the beta phase. Okay. So here I have liquid plus alpha. Here I have liquid plus beta. Here I have alpha plus beta. Now you can see at this point, the conversion is from when I cooling down liquid plus beta on cooling changes to alpha phase. Okay. Now this takes place at peritectic temperature, that is TP. Okay. Now here these two lines are the liquidus lines. This is liquidus line. This is liquidus line. Okay. And this one is the solidus line. This one is solidus line. Okay. And these two are the solvus lines. Okay. So this is peritectic diagram. The next is peritectoid diagram. So in this diagram, peritectoid reaction takes place. That means two solids on cooling at peritectoid temperature changes into one another solid phase. Okay, so this diagram is something like this. So here is A, here is B, this is my temperature. Okay, so this is gamma region, one solid phase region. This is alpha region and this is beta region. Here I have gamma plus beta. Here I have gamma plus alpha. Here I have alpha plus beta. Okay. So along this line, at this point, this reaction takes place, that is peritectoid reaction. Means two solid phases, gamma plus beta changes to alpha phase. So this is peritectoid diagram. The next is monotectic diagram. So here in this diagram, the monotectic reaction takes place, that is L1, one liquid phase changes into another liquid phase plus one solid phase. Okay, so this is monotectic reaction. Okay, so in this reaction, liquid phase transforms into solid phase and another liquid phase of different composition. Okay, you can say here liquid phase transforms into a solid phase and a liquid phase of different composition. So here, over a certain range of compositions, the two liquids are immiscible. Okay, so here the two liquids are immiscible, that is like oil and water. Okay, so they constitute individual phases. Like oil and water, the two liquids are individual phases or different phases. Okay, so thus monotectic reaction can said to be associated with miscibility gaps in the liquid state. Okay, now the example for monotectic system is copper and lead. Okay, so at 954 degrees centigrade and for 36 percentage of lead composition, this reaction takes place. Okay, monotectic reaction takes place. Okay, now you see the monotectic phase diagram. So that is something like this. Okay, so along here I have temperature. Here I have copper. Here is lead. Okay, so I have one line over here. So this point is something like this. So this point is at 36%. So along this I have weight percentage of lead. Okay, so if I talk about the phases. Here I have liquid phase L1. Okay, so I have one more line over here. Okay, so this is here I have another phase L2 along this side. Okay, and in between I have L1 plus L2. Okay, so here I have alpha plus L1 phase. Here I have L2 plus alpha phase, and below this line I have alpha plus beta phase. Okay, so this line is at approximately 326 degrees centigrade. This is at 954 degrees centigrade. Okay, so here a weight percentage of 87%. Okay, so this is my monotictic diagram. Okay, so this exists in copper lead system. Okay, so this is all about different types of phase diagrams.